Okay, it's fine. So we can start. So guys, this is today we're going to do type 2, né? Or they call it the type of f at x prime divided by f at x. Né? If you can remember on the type that we were doing yesterday, I said the first thing you have to identify your f at x, né? On type 1. And how do you identify your f at x? I said it will be inside the bracket and also having what? To the power of something. Né? Alright, okay. But on this case, you're going to identify your f at x, whereby you see that now your f at x, it won't be inside the bracket, or it won't be having any exponent. Né? So you're going to take your f at x as your denominator, and then you're going to derivate it. Né? And then after that, what you do, you correct. You do the same thing that we're doing. You're going to correct, and then after you you introduce your integration formula. Né? Okay, let's say for example, I'm given number 1 integral of 2x dx divided by x to the power 2 plus 5 dx. Alright, okay. Okay, please do not write. I'll give you a time to write. Okay, let's say for example, you are given this integral equation. Do you see that on this one I cannot apply type 1? Reason being, I don't have my value of f at x inside the bracket and also having what? An exponent. Eh? So I cannot bring this one up because it's not inside the bracket and it's also not having an exponent. So definitely I cannot use type 1, which means I can use what? Type 2. So on type 2, what do you have to do? You have to identify your f at x. Ne? And how do you identify your f at x? If you check from this, my f at x is going to be the denominator. Ne? So you're going to derive your f at x. So this is my f at x, which is x squared plus 5. Ne? The same thing that we were doing that day, and then we have to derive these. What is the derivation of this? 2x. It will be 2x. Okay, check on your formula. It says f at x prime divided by f at x dx. Ne? So I said you have to correct with your f at x prime. Ne? Check. Here I'm having 2x. Here I'm having what? 2x. Is there need for me to correct? There is no need. Both this thing is the same as this. Ne? And I said you only correct with the negative or what? Or a number. Ne? But on this case, there's no need for me to correct anything because I see my f at x prime and this one, they are the same. Ne? Which means now I can just integrate using this formula. So it's going to be what? Equals to ln, open bracket. What is my f at x? Is this, ne? Which is x squared plus 5. And then I said to show that you have integrated, you write plus c. Ne? Then you are done. So the most important thing, you have to identify your f at x first. You have your f at x, you're going to derive your f at x, you get your f at x prime, and then you correct. Ne? You check if it is the same with the original equation. Ne? After you correct, and then you introduce your formula, and then you write plus c to show that you have integrated. Ne? You can code this. Okay, let me also. Okay, let us just do this one. Since I'm recording this, it's gonna be long if I wait for you to copy. Okay, then I will give you a time to copy. Let's say for now, I'm given the integral of what? Of x squared dx, and then divided by a plus b x cubed. Alright, okay. As I said, I can see that it's not inside the bracket, not having any exponent on the bracket. So this is definitely my type 2. Ne? And then what do you do first? You identify your f at what? F at x. I said you're going to take your denominator, which is a plus b x to the power 3. Ne? And then what you do, you have to derive this f at x prime. What is the derivation of this? A is just like a constant. Ne? And remember, derivation of a constant is what? It's 0. Ne? And then I have here, I'm going to have what? 3 b x to the power 2. Ne? Alright, okay, let's correct here. I said you have to correct to make your f at x prime the same as what? As your numerator. Ne? So here I'm having x squared, here I'm having 3b x squared, which means I have to correct with what? With 3b. Ne? If I correct with 3b, if I need this to be cancelled, I said, what do? You're going to write the other one outside the bracket, which is 1 over 3b. So if you want to take it back to the original equation, if you multiply this thing, it's going to cancel. So make sure when you introduce something inside the bracket, you have to introduce the other one outside. So when you multiply, it can cancel. The same thing that we were doing last time. And then I have corrected. And then what do? I go to my formula. And I said you're going to say 1 over 3b, which is outside the bracket, ln, open bracket, ln of what? What is my f at x? It's a plus bx to the power 3. Then I close the bracket, plus c. Is it difficult? No. Okay. Let us try another one before you copy. Okay. Integral cosine x cos x divided by 3 sine squared x plus 2 cos. Alright, okay. So let's say, for example, you have an equation like this one. Okay, I said the first thing you have to identify your f at x. Okay, how do I identify my f at x? I'm going to check my denominator. So which is my f at x is same as what? 3 sine squared x plus 2 cos squared x. And then what do you have to do with this? You have to derive this. Okay, f at x prime. What is the derivation of the? Remember I said when you have sine squared x is the same as what? Sine x squared. So what is the derivation of this? I'm going to drop my 2, which is going to be 3 multiplied by 2. I'm going to have what? 6 sine x. Okay, what is the derivation of sine? It's negative or it's cos? It's cos. Please make sure you don't confuse this thing between integration and differentiation. It's cos x. Alright, okay, and then I go to this side. What's the first thing? I drop down my 2, so it's gonna be 2 multiplied by 2. So it's gonna be plus 4. And then what is the derivation of what? Cos x. And then what is the derivation of cos? It's negative. Negative sine x. Okay, this is the same as what? 6 sine x cos x minus, was I have a negative here? Minus 4 cos x sine x. Do you see that I have light terms here? Was I have 6 sine x cos x, I have 4 cos x sine x. These are light terms. So I can subtract here. The same as 6 minus 1 minus 4. Okay, I'm going to have 2 sine x cos x is my f at x prime. Alright, okay. And then now I'm done simplifying this. I have to correct with my numerator. So do you check what's the difference on my numerator? I have sine. Sorry, I forgot to write the x here. The only difference is 2. So I can correct it here with what? With 2. And I said for you to make it cancel here, you have to multiply the 1 over 2. And then you go to your formula, so it's going to be 1 over 2, which is outside the bracket. And then ln of my f at x, which is what? Which is this. Okay. Plus c. Alright, okay. So the most thing that you have to do, same thing with type 1 and type 2, you have to identify your f at x first. You have your f at x, you're going to derive. After derive, you have to correct, and then you apply the formula. Simple as what? Simple as that. You can copy this.